The stimulated emission of light was a discovery by Einstein around 1916. All we need is an atom which possesses electrons just like any other atom in our world and a photon, that is, a quantum of light. The atom has electrons orbiting the atom's nucleus. For a better understanding, the Bohr model of the hydrogen atom will be used. The hydrogen atom has only one electron. The atom and the electron are on the ground state, namely E0. However, an electron may have other discrete values of energy. For this example, two energy levels will suffice, E1 and E2. An electron can be excited to a higher energy level by absorbing a photon whose energy is equal to the energy difference between the levels. The electron is said to be excited. However, after a very short time, the excited electron will go to the lower energy level by emitting a photon equal to the energy difference. This is called spontaneous emission. But when an atom absorbs a photon, and after a short time another photon is absorbed, a stimulated emission will be the result. The newly created photon has the same phase, frequency, polarization, and direction as the second photon. So it's a copy. The operation of lasers is based on the process of stimulated emission. Here we will discuss a three-energy level design. A photon is absorbed by the atom. The photon has enough energy to lift the electron from energy level E0 to energy level E2. Shortly afterwards, the electron jumps into energy level E1. This can occur without emission of a photon. A laser device is made up of several components. First of all, a mirror with a reflectivity of 100% is installed at one end of the device. Furthermore, we need a gas, a liquid, or a solid that serves as the gain medium and creates identical photons. Another mirror with a reflectivity of about 98% must be installed at the other end of the gain medium. Another part we need is an energy source in order to use photons to raise electrons from a lower energy level to a higher one, a process called optical pumping. Now, let's have a look at the inside of the gain medium. The atom and the electron are on the ground state. Now, optical pumping, that is, emitting energy in the form of photons, is used to raise the electron into a higher energy level. In this case, its energy level is E2. After a short period of time, the electron jumps into energy level E1 without emission of a photon. Consequently, the process of optical pumping cannot cause stimulated emission because there are two different amounts of energy present. The electron will maintain its energy level E1 for some time. Then, the atom will spontaneously emit a photon in a random direction as it relaxes to a lower electronic state. This photon may interact with an excited atom that hasn't emitted a photon yet. So, the photon hits the excited atom and causes a stimulated emission because the photon has the exact amount of energy to do that. Only photons emitted in a direction perpendicular to the mirrors will be reflected. The reflected photons initiate a chain reaction to produce more and more photons of the same kind. Furthermore, only photons with the same amount of energy and the same momentum will be part of the chain reaction. That's the reason why laser beams are strongly coherent and monochromatic. A very important aspect is the fact that many atoms must be in an excited state. For a laser to work, more atoms must be in an excited state than in lower energy states. This is called population inversion. The semi-transparent mirror allows some of the laser energy to be emitted, while bouncing most of it back through the laser. There are many other cool things about lasers, but for now, that's all.